Good morning, all of you. Welcome to Sri Jayendra Rank Zone. So far we have completed in lecture 3 questions based on KP and KC. So now we are going to discuss new topic in this chapter, that is applications of equilibrium constant. Applications of equilibrium constant. So with this lecture we can finish off KP and KC and equilibrium constant. And next we have one more topic, that is Neet Iit-Jee's principle. So now we are going to discuss application of Neet Iit-Jee's principle. So let us see now. This is also important concept. In this one, important concept is there. So please note it down. Now coming to applications of equilibrium constant. Application of equilibrium constant. Now we are going to discuss. So first application, very, very important. It helps in predicting the direction of reaction. It helps in the predicting the direction of reaction. How it helps in the predicting the direction of the reaction, whether the reaction is taking place in forward direction or backward direction, we can see by using the value of Kc, that is equilibrium constant. So first one, reaction quotient. So at each point in a reaction, we can write a ratio of concentration terms having the same form as the equilibrium constant expression. This ratio is called the reaction quotient and denoted by the symbol Q. It helps in predicting the direction of reaction. So from Kc, we can get the values of Q. Same like how we will calculate Kc. Kc is equal to concentration of products raised to the power of the stoichiometric coefficients by concentration of reactants raised to the power of the stoichiometric coefficients of the reactants. So this is how to find Kc. In the same way, you will also find Qc also. So at each point in a reaction, we can write a ratio of concentration terms having the same form as the equilibrium constant expression. This ratio is called the reaction quotient, denoted by the symbol Q. It helps in predicting the direction of reaction. So Q, based on Q value, we can say it helps in the direction of prediction of the reaction, whether the reaction is taking place in forward direction or backward direction, or whether the reaction is completed or the reaction doesn't take place. So all these points we can understand. So let us see. So this is the reaction quotient graph with respect to time. So reaction quotient keeps on going like this, constant value, and equilibrium is reached, it becomes constant. So equilibrium will be going like this. So the expression Q, as I told you, Q also will find same like equilibrium constant. Q is equal to concentration of C whole to the power of C, concentration of D whole to the power of D, by concentration of A into concentration of B whole to the power of A and whole to the power of B respectively. At any time during reaction is called reaction quotient. So Q at any time we can find, but equilibrium will calculate for total reaction. But Q we can calculate at any time. Means either in the forward direction or in the backward direction we can calculate Q, but Kc will calculate only at equilibrium. So that is the main difference. See, I'll write it here. Please note it down. Q can be calculated. Formula is same for both Q and Kc at any instant. At any instant. Whereas Kc is calculated at equilibrium only, but formula is same, at equilibrium only. So whereas Kc. So this is the difference between Q and Kc. So the expression Q is also the same formula, that is concentration of products by concentration of reactants raised to the powers of the stoichiometric coefficients. At any time during chemical reaction is called reaction quotient. The concentrations of A, B, C, D are not necessarily at equilibrium. So that's what the difference. They are not necessarily at equilibrium. For any given chemical reaction, we can calculate Q. But Kc will be calculated only if they are at equilibrium. If they are at equilibrium only. So that is a major difference between Q and Kc. Next, continuation. The reaction quotient is a variable quantity with time. It's a variable quantity with time. It helps in predicting the direction of a reaction in the following way. Very, very important. These words are very important, these points, because they'll ask in the objective competitive exams. If Q is greater than Kc, Means if the reaction quotient is greater than the equilibrium constant, we can say the reaction will proceed in the backward direction until equilibrium is reached. Until equilibrium is reached. So if Q is greater than Kc, reaction proceed in backward direction until the equilibrium is reached. Similarly, that is reverse direction. Backward direction means what? Reverse direction. And suppose if Q is less than Kc, reaction will proceed in forward direction, that is forward direction until the equilibrium is established. So if Q is greater than Kc, reaction will proceed in reversible direction or backward direction until the equilibrium is reached. And if Q is less than Kc, reaction will proceed in forward direction until the equilibrium is established. If Q is equal to Kc, we can say the reaction is at equilibrium. So in this way, Q is helpful in predicting the direction of reaction. In this way, Q is helpful in predicting the direction of the reaction. What are the three conditions? Again, I'm repeating, please listen carefully. If Q value is greater than, how to calculate Q? Q can be calculated by using the same formula, that is concentration of products by concentration of reactants raised to the power of their stoichiometric coefficients. And if you calculate Q and if you compare with Kc, Q can be calculated at any instant of the reaction, but whereas Kc will be calculated only at equilibrium. And if you compare Q and Kc, if Q is greater than Kc or Kp, Kp also you can take in terms of pressures. So if Q is greater than Kp or Kc, you can write Kp also here because Kp also will applicable for this. So if Q is greater than Kc, reaction will proceed in reverse direction or backward direction until equilibrium is reached. Similarly, if Q is less than Kc, reaction will proceed in forward direction until equilibrium is established. And if Q is equal to Kc, reaction is at equilibrium. So all these 3 points are important. That's why we can say straight away the reaction quotient is a variable quantity with time. It helps in predicting the direction of reaction. It helps in predicting the direction of reaction, whether the reaction is at equilibrium or if it is whether the reaction is in forward direction or whether the reaction is in backward direction. And even we can say, even by the means of Q value, we can say even the reaction is completed or the reaction will never takes place. So that also we can do. So this is the explanation of Q versus Kc. Very, very important topic. Please note down in your classwork. Based on this concept, also they will ask question in JE mains and NEET and advance also on any entrance exam. So these 3 points are very key points. So please note it down. Next, consider an example, applications of equilibrium concept. 2a plus b gives rise to c plus d. So here 2a plus b gives rise to c plus d. So we can say QC is equal to, in terms of concentration, QC is equal to concentration of C, because it is only 1 mole, into concentration of D divided by concentration of A square, because A is 2 moles, and concentration of B. So you can see here concentration of C, concentration of D, this concentration of products by concentration of reactants raised to the power of the stoichiometric coefficients. Raised to the power of the stoichiometric coefficients of reactants as well as products. So here the reactant 2A is there, so 2 moles, so that's why A square. This already we know. Now Kc is equal to concentration of C equivalent, very, very important here. Q can be taken as at any instant of the reaction, but C will be definitely equilibrium concentration only. Concentration of C at equilibrium, concentration of D at equilibrium, concentration of A square at equilibrium, concentration of B at equilibrium. These two will change. That's what we are discussing now. So that is a major difference between QC and KC. QC is called reaction quotient. It can be taken in terms of concentration like equilibrium constant, but here QC can be taken if the reaction is in forward direction or backward direction also, but Kc will be taken only if the reaction is at equilibrium. Here all the concentrations are at equilibrium. This point is very important. So you can see here all the concentrations are at equilibrium, and here they are not necessary at equilibrium. They are not necessary at equilibrium. They are not at all at equilibrium. So we can say by using QC value, we can say whether it is equilibrium or not. So that's why we can say this is the difference between QC and KC. Very, very important. Please note it down in your classwork. So QC cannot be necessary at equilibrium. All the constitutions are not necessary at equilibrium. But whereas Kc compulsory, all the concentrations of the reactants and products should be at equilibrium. Here, all the concentrations are at equilibrium. So this is most important. Continuation, example 1. Now, equilibrium constant Kc for the reaction nitrogen plus hydrogen gives rise to ammonia at 500 Kelvin is 0.061. So here they are given Kc value, equilibrium constant. At a particular time, the analysis shows that the composition of the reaction mixture is 3 moles per liter of nitrogen, 2 moles per liter of hydrogen, 0.5 moles per liter of ammonia. So they are given the concentrations of nitrogen, ammonia, as well as hydrogen. Is the reaction at equilibrium or not? If not, in which direction does the reaction tend to proceed to reach the equilibrium? So for this case, we need to calculate Q. QC is equal to concentration of nitrogen, that is ammonia whole square, by concentration of, we have to compare the value of Q with Kc. Concentration of nitrogen into concentration of hydrogen whole cube. So if you do this concentration, if you find these values, that is ammonia is how much? 0.5 into 0.5, because 0.5 whole square, by 2 moles of hydrogen, 3 moles of nitrogen, by 3 into 2 cube, 2 cube. So if you calculate this, if it is less than Kc, we can say about, we have to compare the values of Qc with Kc. So you can see now here 0.5 into 0.5, let us multiply now. 0.5 into 0.5 is equal to 0.25 divided by 3 into 8, 24, divided by 24. Because 3 into 2 cube is 8, so 3 by 24 is equal to 0.010, 0.010. 104, approximately it is 0.010. Since Kc is equal to how much? 0.061. So 0.010, 0.061. So we can say Q is less than Kc. As Q is less than Kc, forward reaction takes place. So like these questions you'll get. So I have given the solution also in the next page. You can just see here. So for this type of questions, first you need to find QC and you have to compare the values with Kc. If QC is less than Kc, forward reaction is taking place. That is, nitrogen combines with hydrogen to form ammonia. If QC is not, if QC is greater than Kc, we can say backward reaction. That is, ammonia is converting into nitrogen and hydrogen. If QC and Kc are equal, we can say the reaction is at equilibrium. So if not, is that reaction is at equilibrium? No. If not, in which direction does the reaction tend to proceed to reach the equilibrium? So it is proceeding in forward direction, that is nitrogen combines with hydrogen to form ammonia. This is the answer. So you can check the answer just like this only you have to do. Anyway, I have given the solution in the next page. So you can see that solution clearly. Let us see the solution now for this. See, QC is equal to, as I told you, 0.5 whole square by 3 into 2 cube, and it is equal to 0.0104. Since QC is equal to 0.0104, it is less than Kc, because Kc value is equal to how much? Kc is equal to, since Kc is equal to 0.061, so Kc is greater than Qc, so Qc is less than Kc, so the reaction is forward reaction, that is nitrogen combines with hydrogen to form ammonia. It is proceeding towards formation of ammonia. So like these questions you'll be getting in the examination, even though they are given Kc values, they are wantonly, they give concentrations of reactants as well as products. When they are given concentration of reactant as well as product, we have to find first Qc, and we have to compare the value of Qc with Kc or Kp. So if they are given Kp also, you can take the same thing. So if Qc is less than Kc, it is forward reaction. Since in this reaction we got Qc is less than Kc, this is forward reaction. So this type of questions are important. Definitely they are going to ask in the entrance exams. So do more questions based on this. Next, applications of equilibrium constant in predicting the rate of reaction. Just you see. Second one, predicting the extent of reaction. First we know in predicting the direction of reaction. Now we can say predicting the extension of reaction, extent of reaction. So similar, since we know K is equal to, that is equilibrium constant is equal to concentration of products by concentration of reactants raised to the stoichiometric powers. So it is negligible when Kc is less than 10 to the power of minus 3, reaction hardly proceeds. So you can say if Kc is less than 10 to the power of minus 3, the reaction hardly proceeds because at this moment there is no reaction. And for this simply I'm writing here, if Kc reaction hardly takes place, hardly takes place, means the reaction does not take place at all. If Kc is greater than 10 to the power of 3, reaction proceeds almost to completion. Reaction proceeds, please note it down. Reaction proceeds almost to completion. And finally, if Kc is in the range of 10 to the power of minus 3, 10 to the power of 3. So if Kc is equal to, if Kc is in the range of 10 to the power of minus 3 to 10 to the power of 3, we can say the reaction is at equilibrium. Reaction is at equilibrium. So this is the second application of equilibrium constant. So please listen carefully. Equilibrium constant also gives you the predicting the extent of reaction, how much the reaction is completed, whether it is completed or yet to start, or is it equilibrium. We can say if Kc is less than 10 to the power of minus 3, we can say reaction hardly takes place. If Kc is greater than 10 to the power of 3, reaction proceeds almost to completion, that is forward reaction is completed. And if Kc or Kp is in the range of 10 to the power of minus 3 to 10 to the power of 3, we can say reaction is at equilibrium. Both reactants and products are significant. So reaction proceeds almost to completion. So here what we can say, products predominates reactants. Products predominates reactants. And here in this case, reaction hardly takes place. Reactants predominates products. Reactants predominates products. So please note it down, very, very important. So if Kc value is less than 10 to the power of minus 3, we can say reaction hardly takes place. In this case, reactants predominates products. Reactants predominates products. So the reaction will never takes place. And if Kc is in the range, if Kc is greater than 10 to the power of 3, reaction proceeds almost to completion. In this case, products predominates reactants. Products predominates reactants. So in this case, they'll form like this. And if Kc is in the range of 10 to the power of minus 3 to 10 to the power of 3, we can say the reaction is at equilibrium. The reaction is at equilibrium. So second application of equilibrium constant, it also helps in predicting the extent of reaction. It also helps in the predicting the extent of reaction. See how nicely it has been explained. So it has been given the diagram also clearly. So please note it down. Very, very important, this concept. So second concept, that is second application, predicting the extent of reaction. So equilibrium constant gives you the extent of reaction. First one, equilibrium constant gives the direction of the reaction, and second one, equilibrium constant gives the extent of reaction. Next, third application, very, very important. If K is large, that is equilibrium constant, Kc we can write, or K, both are same. So if you write Kc, it could be better so that you can understand better. If Kc is large, K is greater than 10 to the power of 3, then product's concentration is very high, larger than the reactant. That's what I told you. Products predominates reactants. Product concentration is greater than reactant. Hence, the concentration of reactants can be neglected with respect to the product. So in this case, the reaction is the product favorable, and the equilibrium will be more in forward direction than in backward direction. Very, very important. So in this case, if K is greater than 3, 10 to the power of 3, the product predominates reactants. So in this case, the reaction is product favorable. So, and equilibrium will be more in forward direction rather than in backward direction. So equilibrium will shift towards forward direction. So that's why this is very, very important. Similarly, next, If K is very, very small, that is less than 10 to the power of minus 3, we can say product is concentration of product is far, far less than concentration of reactant. Concentration of product is far less than concentration of reactant. It means reactants predominates products. Predominates reactants predominates products. So, as reactants are predominating products, the hence concentration of products can be neglected as compared to the reactant. In this case, the reaction is reactant favorable, means backward direction, or you can say reaction hardly takes place. We can say, in other words, reaction hardly takes place because the products will not be formed. Hardly takes place because the reactants will be like that only. So no products. So that's why we can say reaction hardly takes place. So next, relation between equilibrium constant and standard free energy. So if Kc is in the range of 10 to the power of minus 3 to 10 to the power of 3, we can say reaction is at equilibrium. Next, we have third application, relation between equilibrium constant and standard free energy. This we have done even in thermodynamics also. This formula, if you can remember, that is free energy change delta G, standard free energy change is equal to delta G degree is equal to minus 2.303 RT log Kc, where R is called gas constant, universal gas constant, T is called absolute temperature, Kc is called equilibrium constant. So where delta G is equal to standard free energy change, delta G is equal to standard free energy change. So this is very, very important. So relation between equilibrium constant and standard free energy change. So delta G is equal to minus 2.303 RT log Kc. So based on this, we have numericals also. So how to find standard free energy change? By using K minus 2.303 RT log Kc. Example 2 now. At the standard state free energy change, delta G is, for this reaction they are asking change in Gibbs free energy, that is standard free energy change, is N2 plus O2 gives rise to 2NO is minus 71.3 kilojoules per mole. They have given delta G value minus 71.3 kilojoules per mole. Calculate Kp for this reaction at this temperature. So they're asking us to find Kp value for this temperature. Kp or Kc is same. So we know the formula delta G is equal to minus 2.303 RT log Kp or Kc. So we can write here Kp. So from this you can find out easily. Since delta G is given, R is given, T is given, R is equal to 8.314, temperature is also given. So at standard state means temperature will be, at standard temperature will be, temperature will be 273 kelvins. So we are given the solution also for this. You can just see this is the answer for finding Kp. Let us see the solution now. So that is minus 2.303 into 8.314 into 10 to the power of 3 because joules per Kelvin, and that is given in kilojoules. See why we have taken R is equal to 8.314 into 10 to the power of 3 because 8.314 is joules per moles per Kelvin. So into 10 to the power of 3, then it becomes kilojoules. Kilojoules per moles per Kelvin. So that's why we have to convert into 3. And 298, this is 25 degrees C because standard temperature means 25 degrees C. Since standard temperature is 25 degrees C, so we can say 273 plus 25 because they are given standard free energy. So 273 plus 25, which is equal to 298. So 298 into log Kp is equal to 71.3 because they are given delta G value 71.3 kilojoules. So Kp is equal to, for this, first we have to find Kp, log Kp is equal to, log Kp is equal to 71.3 divided by, minus and minus gets cancelled because here this is also minus, this is also minus. So minus and minus gets cancelled. So 71.3 divided by 2.303 into 8.314 into 298 into 10 to the power of 3. So by calculating this, you will get Kp value, log Kp value. So by this, we can say Kp is equal to anti-log of this value, anti-log of this calculation. So answer finally you got it as 3.2359 in 10 to the power of minus 13. 3.2359 in 10 to the power of minus 13. So like this, you have to solve the question. 3.29 10 to the power of minus 13 is the answer. So Kp or Kc, we can find out. Next question. Delta G value is given 77.77 kilojoules per mole. That is standard free energy change value is given at 1000 kelvins for the reaction half N2 plus half O2 gives rise to NO. What is the partial pressure of NO? Very, very important this model. These are all advanced level problems. So that's why we have to be very cautious. So what is the partial pressure of NO under equilibrium at 1000 kelvins for air at 1 atmospheric pressure containing 80% nitrogen, 20% oxygen by volume? So they are given number of moles of nitrogen as well as number of moles of oxygen. Since they are given number of moles of nitrogen, number of moles of oxygen, we can find out total pressure as well as partial pressure. Total pressure is also given 1 atmosphere. So we can easily find partial pressure of nitrogen oxide. So answer is given here, but solution is being given clearly. So first let us see now how to calculate this question. So delta G is given 77.77 kilojoules per mole at 1000 kelvins. Temperature is also given. First we need to find Kp value. From Kp we can find partial pressure. So let us see the detailed solution for this. See, delta G is equal to minus 2.303 RT log Kp. So that is 77.77 is equal to 2.303, 8.314 10 to the power of minus 3, because it is given in joules. So into 10 to the power of 3 log Kp. Why you got 10 to the power of 3? Because this is temperature. Because R is at 8.314 10 to the power of 3. And T is what? Temperature is 1000 kelvins. So Kp is equal to 8.7 10 to the power of minus 5, which we got it as Kp is equal to, we know, partial pressure of, what is the formula for finding Kp for this question? Kp is equal to partial pressure of nitrogen oxide by partial pressure of nitrogen whole to the power of 1 by 2 into partial pressure of oxygen whole to the power of 1 by 2. So this is 0.8 and 0.2 is given already. So straight away we can substitute and we can find partial pressure of nitrogen oxide is equal to 3.48 in 10 to the power of minus 5. Because this is given, this is also given. 80%, 20%. Since they are given 80%, we can take it as 0.8, 20%, 0.2. And why we got root? Because whole to the power of 1 by 2. Because the reaction is half N2 plus half O2 gives rise to NO. Since half and half is there, so we need to take square root, because 1 by 2 is square root only. So like this we have to do. It is clear. Next question. The value of delta G for the phosphorylation of glucose in glycolysis is 13.8 kilojoules per mole. Find the value of Kc at 298 kelvins. They are given delta G value. They are asking us to find Kc. So delta G is equal to minus 2.303 RT log base 10 Kc. Since they are given delta G degree value minus 13.8, this should be minus only, because if delta G is negative, then only the reaction takes place. If delta G positive, the reaction will never take place. As the reaction is not taking place, we cannot calculate Kc also. So that's why minus and minus gets cancelled. So delta G, that is minus 13.8 kilojoules per mole, or you can say 10 to the power of 3, is equal to minus 2.303. R value is 8.314 into T value. T value is how much? 298 kelvins is already given, into log base 10 Kc. Log base 10 Kc. So it is nothing but log Kc. Log base 10 Kc. By this you can say log Kc is equal to log Kc is equal to minus the minus and minus gets cancelled, 13.8 into 10 to the power of 3 divided by 2.303 into 8.314 into 298 into 298. So after calculating this value, you'll get it as 13.3 point. So Kc is equal to, anti-log of this value, anti-log of the value, which we are going to calculate after this. So this calculation part, you can do it, or else if you want, you can, I'll do it here. So 13.8 in 10 to the power of 3 is how much? 13.8 into 1000, that is 13,800. So that is equal to 13,800 divided by 2.303 into 8.314 into 298 is equal to 5,705, 5705.84. So this could be 13,800, 13.8 into 1000. So we can take it as 13,800 divided by 5,705.84 equal to 2.418 is equal to antilog of 2.418. Antilog of 2.418 is approximately 3.81 in 10 to the power of minus 3. 3.81 in 10 to the power of minus 3. In this way, you have to calculate. Here, instead of taking 8.314 in 10 to the power of 3, I have taken 13.8 into 10 to the power of 3 because kilojoules is given. So I have converted into joules per mole because this is in joules. So that's why you have to convert into 10 to the power of 3. That is 13.8 into 10 to the power of 3. It is kilojoules per mole. So in this way, you have to consider. So I have given the detailed solution. That also you can see here. Delta G is equal to minus 13.8 kilojoules per mole. That is 13.8 in 10 to the power of 3 joules per mole. So delta G is equal to minus RT IN Kc. That is natural logarithm ln Kc. So minus 13.3 in 10 to the power of 3 joules. R is equal to 8.314. So Kc is equal to, that is log Kc is equal to minus 5.569. So it is equal, Kc is equal to anti-log of, that is e power minus 5.569. It is equal to 3.81 10 to the power of minus 3. Even you can take ln, that is natural logarithm, e power minus, or you can take anti-log. Both are same. Next question. 13 grams of N2O4 was placed in a 1 liter reaction vessel at 400 kelvins and allowed to attain equilibrium, that is N2O4 changes to N2NO2. So 13.8 grams of N2O4 is kept here. The mass of nitrogen, dinitrogen tetroxide is also given, and the volume is given, vessel at 400 Kelvin. So all these three are given, means definitely I had used PV is equal to nRT. So the total pressure at equilibrium was found to be 9.15 bars. So total pressure is also given. Calculate Kc, Kp and partial pressure at equilibrium. So they're asking us to find equilibrium constant Kp, Kc and Kp also. For equilibrium constant Kc, we have to find first volume by using this reaction. So PV is equal to nRT. Since PV is equal to nRT, we can take, we know n moles of also, because number of moles is equal to. So first we can find from PV is equal to nRT. Why we are finding volume? To find concentration, because for Kc we have to find concentration. So since PV is equal to nRT, so we can say V is equal to nRT by P. Also we can write V, N is equal to weight of the solute by molecular weight into R into T by P. So R value you should take it as 0.083. R value how much you should take? 0.083. So straight away you can substitute the value, you'll get the answer of volume. Once after getting volume, N by V is called molarity, that is concentration. So once, if you know the concentration of N2O4 as well as NO2, we can find out the answer easily. So let us see the solution. I have given it clearly in typing only. So you can see here the solution. Sorry. We know that PV is equal to nRT. Total volume becomes 1 liter. So molecular mass of N2O4 is dinitrogen tetroxide. So nitrogen is 28 plus oxygen 64. N2O4 molecular weight. So 16 4 is 64. It is equal to 92 grams. So number of moles is equal to 13.8 divided by 92 grams. So it is equal to 0.15 of the gas. So gas constant R is equal to 0.083, as I already told you. And pressure is given as 4.98 bars. So initial pressure is 4.98 bars. We have to find the volume pressure. So from using the equation, PV is equal to nRT by V. So we know the value of N, we know the value of V. So find a way. First right away you can find out pressure because temperature is also given 400 kelvins. So PV is equal to nRT. So P is equal to nRT by V. So by substituting that, you got P is equal to 4.98 bars. Initial pressure is 4.98 and it has zero pressure. This becomes 4 N2O4. This is gives rise to, so 4.98 minus X bar is equal to X bar because 2 moles of this is formed. So first we'll find degree of dissociation, that is X. Then we can find out Kc also after finding Kp. So hence P total at equilibrium is equal to P partial pressure of N2O4 plus partial pressure of NO2 because total pressure is equal to, and total pressure they are given 9.15. It is already given. Since total pressure is already given 9.15, so we can say 4.98 minus X plus 2X is equal to 9.15. From this we can find X value, that is degree of dissociation. Carefully observe the step. So 4.98 minus X plus 2X, it becomes 4.98 plus X is equal to 9.15. By this we can say X is equal to 4.17 bars. So this is the equilibrium pressure. This is what pressure? This is degree of dissociation. Degree of dissociation. This is called degree of dissociation. So partial pressure at equilibrium are, partial pressure is equal to 4.9 minus 4.17, that is 0.18 bars. And partial pressure of nitrogen dioxide is equal to, because this is a degree of dissociation, so 2 times of X, that is 2 into 4.17, that is 8.34 bars. By this we can find out easily Kp, because Kp is equal to partial pressure of nitrogen dioxide square, because 2 moles of nitrogen dioxide by partial pressure of N2O4. So 8.34 square by 0.81, it is equal to 85.87. Since Kp is equal to 85.87, we can say from the relation Kp is equal to KCRT whole to the power of delta N. And for this reaction, delta N value is equal to how much? It is equal to 1, because delta N is equal to 2 minus 1, it is equal to 1. So 0.083 into 400 power 1 is equal to 85.87. So after this Kc is equal to 2.586 is equal to 2.6. So in this way you have to calculate. So this is very, very important numerical. This is also usually they'll give it for this much lengthy problem, they'll give it for advanced level. For advanced level problem, it is important. Next question. So one more question I want to add it here so that it will be easy for us to understand this concept more. They are given this question for advanced IIT advanced question. Advanced. This is 2015 question. Year 2015 they are given based on this concept. So that's why I want to discuss this. So let us start now. Question. Simply I am given question number 6. The standard Gibbs energy change. The standard Gibbs energy change. Gibbs free energy change. Our energy change they are given. The standard Gibbs energy change at 300 kelvins for the reaction. For the reaction 2A gives rise to B plus C is 2494.2 joules. 2494.2 joules. Very interesting question they have asked. At a given time, the composition of the reaction mixture is the composition of the reaction mixture is concentration of A is equal to 1 by 2, concentration of B is equal to 2, and concentration of C is equal to 1 by 2 again. Predict the direction of reaction. Predict the direction of reaction. See this problem, they have extended one more. So that is nothing but predict the direction of reaction. Here I'm not giving options because anyway it can be forward direction or backward direction or it will be. So options will be the same. So they are first what they are given, the standard Gibbs energy change at 300 kelvins for the reaction 2A uses to B plus C is 2494.2 joules. At a given time, the composition of the reaction mixture is concentration of A is equal to 1 by 2, concentration of B is equal to concentration of C. This is addition part because from this we know how to calculate Kc, and from this data we can know how to calculate Kc. After finding Kc, we have to find Q also. From this data we can find Q. What is that Q? Q is called reaction quotient. That is A is equal to 1 by 2, B is equal to 2, C is equal to 1 by 2. So direction of reaction. So we can say if Q is greater than Kc, if Q is less than Kc, we know the conditions. So first we'll find Kc for this reaction. So I'm doing the solution with the blue color. So Kc is equal to, so delta G is equal to, solution now I'm doing delta G is equal to minus 2.303 RT log Kc. So we can say log Kc is equal to, delta G value is 2494.2 joules only they are given, divided by 2.303. This minus and minus, anyway this is all should be given minus, but they are given plus anyway. This should be, this will become plus anyway. So 2.303, oh minus only will keep, no worries. So 2.303 with minus sign into R value is given 8.314 into T value. We know T value is what they are given 300 kelvins. So 300 kelvins. So this could be equal to 2494.2 divided by 2.303 into 8.314 into 300, that is equal to 5744.14, nothing but it is 292494. So that is 2494.2 divided by 5744.1. Just only one decimal I'm taking. So it is equal to 0.4. So log base in 0.43. So it is approximately, since log base 10 is Kc is equal to 0.43. So Kc is equal to, so you know log 4 value, it is 0. Log 3 value is 0. What is the value of log 3? It is 3 log 10 is equal to 0.477. So it is equal to Kc is equal to, we can say, since it is 0.437, it is approximately Kc is equal to log 3, that is log Kc is equal to 0.477437, so on. So we can round it up to, we can round up, since it is equal to, by this you can say Kc is equal to 3. Now as we got Kc is equal to 3, we can find out Q value. Q is equal to how much? Q is equal to, that is react products, that is concentration of B. What is concentration of B? 2 into concentration of C, that is 1 by 2 divided by concentration of A to the power 2. Concentration of A is 1 by 2 whole square. 1 by 2 whole square. So there is 1 by 2 whole square, that is Q square is equal to, so Q is equal to, we got 2 square will come to numerator. So Q implies Q is equal to 4. Implies Q is equal to 4. Implies since Q is greater than Kc, QC is greater than Kc, we can say reverse reaction takes place. The reaction will proceed in reverse direction. That is backward reaction. Because since Q is greater than Kc, the reaction proceeds in reverse direction. So this question has come for IIT Advanced 2015 question. what they are given, the standard Gibbs energy change at 300 kelvins for the reaction 2A gives rise to B plus C is 2494.2 joules. At a given time, the composition of the reaction mixture is concentration of A is equal to 1 by 2, concentration of B is equal to, concentration of C is equal to 1 by 2. So predict the reaction, direction of the reaction. We need to find the direction of the reaction, whether it is forward direction or backward direction or at equilibrium. So for that, we need to find first Kc. From how to find Kc by using delta G value. From delta G, we can find log Kc. Since delta G log Kc is equal to 2494.2 by minus 2.303 into 8.31 into 300. So it is approximately coming 0.437. Since 0.437 means approximately it is less than 3, that is almost, because log 3 value is equal to 0.47. Log 3 is equal to 0.477. So it is very close to log 3. So log 3 is, by this we can say Kc is equal to 3. Since Kc is equal to 3, Q is equal to product. What is the product here? B. 2 into concentration of C, 1 by 2. 2 into 1 by 2 gets cancelled. It is 1 by 1 by 4. 4 will come to numerator. So it becomes Q is equal to 4. So by this you can say QC is equal to 4. Since QC is greater than KC, we can say the reaction takes place in reverse direction. So this type of questions are most important. Even for NEET and JE means also. NEET and JE means also. So please copy down this solution. First step, step 1, step 2, then step 3, then step 4. So total 4 steps, we will get the answer. Is it clear? I hope it is clear. Very, very important question, because they are given standard Gibbs free energy change at 300 kelvins is given. For the reaction 2A gives rise to B plus C. So for this, how we got Q? Q is equal to what? Concentration of products by concentration of reactant. What is the product? Concentration of B, that is 2 is given. Concentration of C, that is 1 by 2 is given, divided by concentration of 1 by 2 whole square. 1 by 2 whole square. So in this way you have to calculate. So since Kc is 3, approximately 3, and Qc is exactly 4. So Qc anyway greater than Kc. Since Qc is greater than Kc, reverse direction takes place. The reaction will proceed in backward direction. Reverse direction, because Q is greater than Kc. Since Q is greater than Kc, the reaction will proceed to reverse direction. So in this way, you'll get the question. So these are the important concepts in this class. Let us see now. So with this, I'm ending this session. Next session, we'll discuss new topic in this chapter. Thank you all.